The concept of planetary boundaries represents thresholds in Earth's environmental systems, within which humanity can safely operate. These boundaries are limits to critical Earth systems, such as climate regulation, biodiversity loss, and biogeochemical flows. Crossing these boundaries could lead to irreversible environmental damage that poses a threat not only to Earth's ecosystems, but to human survival and prosperity. This framework helps to define a safe operating space for humanity by identifying the essential processes that keep Earth in a stable state. One specific example of a planetary boundary is the concentration of atmospheric carbon dioxide. The safe limit for this boundary is considered to be around 350 parts per million, or ppm, to maintain a stable climate, similar to the one in which human civilizations have thrived. Current measurements show atmospheric carbon dioxide has risen well above 400 ppm and continues to climb, placing us significantly beyond this planetary boundary. Carbon emissions beyond this threshold contribute to climate change, resulting in more extreme weather, higher sea levels, and disrupted food production systems that threaten food availability. Research and investment in renewable technologies such as solar and wind energy seek to decrease carbon output and restore atmospheric carbon concentrations to safer levels. This idea of planetary boundaries connects to various topics. Biodiversity is crucial for maintaining ecological balance, aiding resilience against ecosystem changes. An intact biosphere supports many processes like pollination and nutrient cycling. The nitrogen and phosphorus boundaries, part of biogeochemical flows, remind businesses about responsible waste management to protect freshwater systems. And IT plays a role in monitoring these systems through data collection and analysis, enabling people to make informed decisions. The Great Barrier Reef provides a striking example of how breaching planetary boundaries can have serious biological consequences. Rising sea temperatures are leading to widespread coral bleaching. Corals rely on a symbiotic relationship with tiny algae that provide food through photosynthesis. High temperatures cause corals to expel these algae, threatening their survival. The loss of coral reefs affects not only the rich diversity of marine life that depends on them, but also human communities that rely on reefs for food and tourism revenue. Protecting these ecosystems requires reducing emissions and exploring restoration efforts. The topic of planetary boundaries weaves into various social and biological discussions. Compromised food systems due to nitrogen imbalance can lead to both biodiversity loss and social unrest. Meanwhile, deforestation contributes to species extinction as habitats are destroyed, and also affects indigenous communities whose lives are closely connected with these forests. Meanwhile, climate change is connected to public health challenges, as rising temperatures can spread diseases and exacerbate conditions like asthma. Understanding these links can drive changes that respect ecological limits while supporting healthier societies and ecosystems.